Hey, it's RandomMathsInc, and today I've got a little problem for you. Let's imagine that you have a ball with a radius of 1 meter, and you take a piece of string and you wrap it around the circumference. Then you'd have a piece of string of a certain length. Now you add an extra meter extension to that piece of string, and you try to wrap that new piece of string with that 1 meter extension back around the 1 meter radius ball. How much will that string be floating from the ball? In other words, if you were to make that string a perfect circle, what would be the size of the gap between the surface of the ball and where the string is? What do you think the answer was? Maybe a gap this big, maybe a gap this big? Or did you say a gap about 16 centimeters? Because that is the answer, 16 centimeters. But now let's think of a bigger ball. Let's think of a ball that has a radius of 6.37 million meters. Let's imagine you take a piece of string and wrap it around the Earth. Wrap it around the Earth's circumference or its equator. Take that piece of string, add a meter extension to it, and then wrap it back around the Earth. What would be the distance between the surface of the Earth and the string? How much will the string be floating off the Earth's surface by? Well, looking at the previous answer, what do you think the answer will be? Is it a few centimeters? Is it a couple of millimeters? Or maybe 60 microns? What do you think the answer is? Well, the answer, in fact, is still about 16 centimeters. And here's why. So let's say you have a circle of a certain radius, which I will call small r. The circumference of that circle will equal to 2 pi r, and if you rearrange for what the radius is, then small r will equal to circumference divided by 2 pi. So now if I take that circumference out, or take that piece of string out, and add a meter extension, the length of the string will be circumference plus 1, or c plus 1. Now if I take that new piece of string with the extension that has the length of c plus 1, and I wrap around to make a circle, that circle will obviously have a larger radius, which I'll call capital R. C plus 1, the length of the new string, will equal to 2 pi times capital R. And if you rearrange it, capital R will equal to c plus 1, the length of the string, divided by 2 pi. And I can change that fraction so that capital R will equal to c divided by 2 pi plus 1 divided by 2 pi, because that's just normal fractions. But wait, c divided by 2 pi, that's the same as little r, or the radius of the circle initially. So basically, the new radius of the circle will equal to the original radius plus 1 divided by 2 pi. So it doesn't matter what the radius of the first circle was, the radius of the second circle will always be 1 over 2 pi meters greater, or 16 centimeters greater. And if you're wondering why I'm in front of my curtains today and not in front of my usual white backdrop, it's because currently my white backdrop has got loads of paper that I'm going to be throwing away in front of it, and so I can't really use it today. You see, I'm moving, so I have to take that piece of junk and take it somewhere, so that's kind of why.